Hi, this is Alex from devstories.eu. Kubernetes and Helm Fundamentals, Episode 7 of 10. You need to update a database password, but the credentials are hard-coded across 15 different YAML files. One missed file and the entire deployment fails. Hard-coding configuration directly into your deployment structure is brittle. The solution is understanding the anatomy of a Helm chart. A Helm chart is a standardized package containing all the resource definitions necessary to run an application, tool, or service inside a Kubernetes cluster. The entire system is built around one core philosophy, a strict separation between structural definition and environment-specific configuration. You define the shape of your deployment once and inject the specific details when it is time to deploy. When you look inside a Helm chart, you find a specific directory layout. The top-level folder is always named after the chart itself. Inside this folder, three core components drive the packaging system. First is a file called Chart.yaml. This is the metadata hub. It tells Helm exactly what the package is. It contains the API version for the chart standard, the chart name, a description, and version numbers. Crucially, it tracks both the version of the chart itself and the op version, which is the version of the actual software being deployed. You might also find a charts directory sitting next to it, which holds any subcharts your application depends on, but the metadata file is the primary identifier. The second core component is the templates directory. This is where the structural definition lives. Inside, you place your standard Kubernetes manifest files, like deployments and services. However, instead of writing static YAML, these files contain Go template logic. Instead of hard-coding a replica count of 3 or pasting in a specific data piece password, you write a template directive. That directive instructs Helm to look up the required value dynamically during deployment. The third component answers those dynamic lookups. It is a file called values.yaml, sitting at the root of the chart directory alongside the metadata file. This file holds the default configuration settings. When a template asks for an image repository, a port number, or a password, the values file provides the baseline answer. Here is the key insight. The templates dictate the architecture of your application, while the values dictate how that architecture behaves in a specific environment. When you run an install command, Helm takes the raw templates, merges them with the values file, and renders final, valid Kubernetes manifests. It then sends those rendered manifests to the Kubernetes API. This separation is what makes charts highly reusable. Consider a scenario where you must deploy the exact same application to both a staging environment and a production environment. You do not copy and alter the chart. You use the exact same directory structure and the exact same templates. For the staging deployment, you pass Helm a custom values file during the install command. This file overrides the defaults, specifying one replica pod, a local test database URL, and strict resource constraints. When you deploy to production, you pass a completely different values file. This production file specifies 10 replicas, a managed database URL, and strict resource constraints. Helm merges the single set of templates with the respective custom values files, producing two completely different deployment profiles. The power of a Helm chart lies not in the YAML it contains, but in the boundaries it creates. It locks down the infrastructure architecture in the templates while keeping the operational details entirely fluid in the values. That's all for this one. Thanks for listening, and keep building.